An insurance company sells two types of auto policies, basic and deluxe. The time until next basic claim is exponential with mean 2 days. The time until next deluxe claim is um, exponential. It's independent from the other one, and that has mean 3 days. Calculate the probability that the next claim will be deluxe. So let X be the number of days until the next claim for basic, because that's what the variable is, time until the next claim. So X be the number of days until next claim for basic, and Y be the number of days until the next claim for deluxe. Now for X, we know that it's exponential with mean 2, so 2 days. So we're writing the PDF instead of the usual CDF, as you will see why below. And GY has the PDF of 1/3 e to the negative y by 3. Remember, exponential is 1 over mean e to the negative x over mean in general. So we need the probability that the next claim will be deluxe. So what that means is that for deluxe, the number of days that elapse from now until the next deluxe is y. And if the next claim is deluxe, then that means that these number of days for the deluxe should be less than the number of days for the basic. That way the y will happen first if y is less than x. So we want py is less than x. So whenever there are two variables involved in the probability that we want to calculate, we actually need the joint density function. We've seen a couple of joint density function before, but now we know when they come up. They come up when the probability expression has two variables in it. So we have the individual density functions, and when the individual density functions are independent, as we are told that the basic claims are independent from the deluxe claims, then the joint density function is simply a product of the two individual functions. So if hxy is a joint density function of xy, so it would just be fx times gy. So multiply the two density functions, and you get this by multiplying the 1/2 and the 1/3. So we need probability y is less than x. So the whole region, the individuals were x greater than 0, y greater than 0, that defines the first quadrant. The whole region is the first quadrant, and we need y less than x. So y less than x is this shaded part. Actually, it's infinite, but it's just like, it looks like that I've drawn a finite triangle, but it's an infinite region. It keeps going in this direction. And this white part is the y greater than x, because this slanted line is the y equals x line, and anything above it is y greater than x, and anything below it is y less than x. And so this region, I've set it up so as to integrate with respect to y first, and then you would choose a vertical strip. So y equals 0 on the bottom of that strip, and y equals x on the top of that strip. So the y limits will be 0 to x, and then x goes all the way from 0 up to infinity. So we then do the double integration first with respect to y. So this x term, or this 1/6 e to the negative x by 2, that's all a constant. So we pull that out. And the integral of e to the negative y thirds is e to the negative y thirds divided by negative 1/3. So that means multiplying by -3. And then I multiply this -3 with the 1/6, and that comes out as a -1/2. So the limits were y equals 0 to y equals x. And when y equals, so the e to the negative x by 2 stays as it is, and we're putting in the limits in this e to the negative y third. When y equals x, it would be e to the negative x thirds, and when y equals 0, it would be e to the 0, which is 1. And then in the next step, you multiply this, distribute this with this, And so negative x by 2, negative x by 3 adds up to negative 5x by 6. And then this time this is just negative x by 2. And then both of them are basic exponentials. So e to the negative 5x by 6 divided by negative 5 by 6, which is multiplying by negative 6/5. And this is e to the negative x by 2 divided by negative half. So that's multiplying by negative 2, and this negative makes it positive, 0 to infinity. And we know that e to the negative infinity is 0. So if I pull the negative half out, so this would be 0 plus 0 when I put in the infinity, because that both terms are e to the negative infinity. And then minus the lower limit, so it means plus this one, plus 6/5 e to the 0, which is 1, and then minus 2 e to the 0, which is minus 2, because e to the 0 is 1 in both. And that ends up being 0.4, which is choice C.